What's up, class? This is our 7th online lecture. We are going to converse about distance formula. I will provide a real-world example, and then you can take a look at some of these solutions that I did for the few problems after this, and let's see if we can solve some of these together. So let's take a look at our real-world example first. Let's just say you are a softball or baseball player. Let's say you play catcher, and you're trying to get somebody out at second. Let's say on the opposing team, some opponent is attempting to steal second base. You are attempting to figure out how far you need to throw from catcher to second base to get them out. Right? So let's figure that distance out. Let's say that from you to first base is our x-axis, and let's say from first base to second base is our y-axis. So let's figure out what this distance would be. Distance formula is distance equals our second value of x subtracted from our first value of x squared plus our second value of y subtracted from our first value of y squared, all under this radicand. So as you can see, our first value of coordinates is 1, 1. Our second value of coordinates is 3, 4. So let's plug and chug. For our second value of x, we have 3, minus our first value of x, we have 1, squared, plus our second value of y is 4, minus our first value of y, which is 1, that's squared. 3 minus 1 is 2, squared, plus 4 minus 1 is 3, squared, that's 4 plus 9. The distance that you would need to throw at, right, is the square root of 13. Let's just say that this is in feet, so that would be the square root of 13 in feet. Now, the square root of 13 is equal to 3.605, etc., etc. So you would need to throw a little bit over 3 feet, almost 4 feet, to second base in order to get that player out. All right, that is a real-world example of distance formula. So let's take a look at some more problems. Let's say now we have this triangle here, and let's say we are trying to figure out the distance between the first point and the second point. Let's figure that out. Distance formula would convey to me that I would indeed need to take my second value for x, which is 5, subtract that from my first value of x, which is 2, square that, and add it to my second value of y, which is 4, subtract it from my first value of y, which is 2, and square that. So 5 minus 2 is 3 squared plus 2 squared, right, which is in fact 9 plus 4, which, funny enough, again, is the square root of 13. So that's my distance here. Let's take a look at one more problem. Again, we are trying to figure out the distance from this line, or this coordinate, to that coordinate. So let's take a look. Again, distance formula is informing me that I need to take the second value of my x, which is 4, subtract that from my first value of x, which is 1, square that, and add that to the second value of my y, which is 3, subtract it from my first value of y, which is 2, square that. 4 minus 1 is 3, squared, plus 3 minus 2 is 1. We square that, all under this radicand. This would in fact be 9 plus 1. The distance for this would be the square root of 10. Right? So what this would in fact mean contextually is that it takes 3.162, etc., etc., etc. steps to get from the first coordinate point to this next coordinate point. All right. If you need any additional help with distance formula, feel free to reach out to me. If you have any other questions regarding mathematics, I would love to answer them. We can think about them together. I hope you guys are having a wonderful weekend, and I look forward to seeing you guys next week. Have a good one.